Beautiful question. Simple enough, but it combines concepts in elementary number properties and counting methods. How many different positive integers exist in this range, 10 power 6 and 10 power 7? Sum of whose digits is equal to 2. If you add up the digits of the number, it should add up to 2. How many such numbers exist is the question. We'll be approaching this question in two ways. The first one is the extrapolation method. This extrapolation method is a beautiful method, works in many cases. What we'll do is we'll check out how many such numbers exist for a lower power of 10. And then we'll figure out what happens in this range 10 power 6 to 10 power 7. Let's pick a range something like 10 to 100, right? This is something where we can quickly identify numbers, sum of whose digits is going to be equal to 2. That is between 10 power 1 and 10 square. This is the range that we are looking at. What all numbers exist? 11 is a number, sum of whose digits is equal to 2. 20 is another number. These are the only two numbers between 10 and 100. How many numbers do we have? We have two numbers. Now let's look at between 100 and 1000. 100 is a 10 square. 1000 is a 10 cube. All of these numbers are 3-digit numbers. What all numbers exist? 101 is a number. 110 is a second number. 200 is a third number. There are only three numbers, sum of whose digits is going to be equal to 2 in the 3-digit numbers. So how many do we have here? We have a count of 3. Let's see if there is a pattern. Between 10 power 1 and 10 square, we find two numbers. Between 10 square and 10 cube, there are three numbers. So extrapolating the same thing, between 10 power 6 and 10 power 7, we'll see 7 numbers. That's it, we got the answer. We'll quickly recap it in a printed form. Between 10 power 1 and 10 square, these are the numbers, 11 and 20. How many count? 2 counts. Between 10 square and 10 cube, how many numbers? These are the three numbers, count is equal to 3. So between 10 power 1 and 10 square, 2 numbers. 10 square and 10 cube, 3 numbers. Therefore, between 10 power 6 and 10 power 7, we'll find 7 such numbers. We'll not stop with this extrapolation. We'll also look at a math method. In the alternative approach, look at this. Between 10 power 6 and 10 power 7, any number is going to be a 7-digit number. If the sum of its digit is going to be equal to 2, there are only two possibilities. The sum can be 2 with a 1 plus 1 being equal to a 2, or one of the digits being a 2. If it's a 1 plus 1 that is equal to 2, 2 of these 7 digits are going to be 1s, and the remaining 5 are all going to be equal to zeros. Here again, let's look at this first possibility. There is one thing that's sure. You cannot have this leftmost digit being a 0. If it is a 1 plus 1 that's giving you the 2, the leftmost digit has to be a 1. We have remaining 6 places, 5 of which need to be filled with zeros, and 1 should be filled with a 1. Where can that 1 go? It can go into any one of these 6 places. So there are 6 possibilities of numbers that start with a 1 and will have 1 in one of the remaining 6 places. So it could be a 1 1 and then 5 zeros, or it could be a 1 0 1 and then 4 zeros, so on and so forth. So the second one could take any one of these 6 places. There are 6 such numbers. The second possibility is a very easy one. Here the number starts with a 2. That's the only possibility. You cannot have a 7-digit number starting with a 0. The remaining digits are all zeros. They will appear in this place. So how many such numbers are there? There is only 1. So what is the total count? 6 plus 1, which is equal to 7. The same count that we got with the extrapolation method. Let's basically recap this in a printed form. In this, we said that all these numbers, if it's a 1, 2 ones which are adding up to a 2, we'll have 2 of these digits being 1s and the remaining 5 will become zeros. How is it going to pan out? The leftmost digit has to be a 1. It cannot be a 0. So what does that leave us with? 6 places where the second one has to happen. So how many such numbers are there? There are a total of 6 7-digit numbers which will have the sum of their digits being a 2, which will contain 2 1s in them. Possibility 2. The leftmost digit is a 2. The remaining ones will all be a 0. So how many such numbers are there? There's only one such number. So what's the total count? Total count is equal to 7. Choice B is the correct answer to this question.